All right, ladies and gentlemen, let's take a look at circles. We're going to take a look at circumference and area, which are things you should be rather familiar with. As we take a look, it's the set of all points, the same distance from a given point, called the center. So the center is important to a circle the same way a vertex is to any of our other polygons. The radius is a segment that starts at the center and goes to a point on the circle. And then we have diameter is a segment across the circle through the center. We need to keep those two straight. So if we think of it, the radius is the shorter word, so it's the shorter segment. And most of you have these things down pat there. Circumference is just the distance around the circle. And so we talked about that, I believe, probably on the day before Pi Day. I talked to you guys a little bit about circumference of a circle, so we'll study that a little bit more. Central angle is an angle whose vertex is the center of the circle, so that should fit the definition. It's in the center of the circle. And then the sector is a region of the circle determined by two radii. It's basically a slice of the circle if we think of a circle as looking like a pie. So you may need to pause, but make sure you get your vocab written down. But let's take a look at these examples. All right, so the circumference of a circle is the product of pi and the diameter, or twice the product of pi and the radius, because it takes two radius to equal a diameter. So one way we can look at this formula is just pi times diameter, or the other way is 2 pi times radius, because the diameter is going to go all the way across, and this is what we would call d. So d is equal to 2 r's. So let's take a look at how we can find that. They tell us to find the circumference. They give us 4 inches for the radius, so we're going to use the 2 pi r. So we substitute 4 in for radius. We're going to simplify that, and it's 8 pi. You can use 3.14, or you can use the pi button. It doesn't really matter. But my answers here are going to have those using 3.14. I'm using what the answer key has there. And so when we take a look at that, we get about 25.13. We need to label that, so 25.13 inches. Okay? So the first checkpoint, we need to go through and find those, what they're asking for. It says to find the nearest, to find the circumference. Round your answer. Here it says to the nearest whole number, ladies and gentlemen. I want them rounded to the nearest hundredths. So that's what we want to see there. So when we take a look at this, we have the radius. This is our r. So we're going to have circumference is equal to 2 times pi times r. So we have 2 times pi times 6. And you can simply type that into your calculator as 12 pi. So if we do 12 pi on our calculator, or 12 times 3.14, we're going to get a circumference of about 37.70 inches. My calculator says 37.699, and that 69 is going to round up to 70, so we're going to write it as 70 there. You're going to do these on your own, so you need to have answers for 2 and 3 to get credit for your notes. All right, let's take a look at the next part of the problem. It's the area of a circle. So the area of a circle is equal to the product of pi and the radius squared. So we're only going to be able to work with the radius in this problem. We may, as we go through, you will figure out what to do once we get diameter. But the only thing we have in this formula is pi r squared. So we'll show you how we're going to deal with this if we're given diameter. So we need to find the area of the circle. I know it's kind of hard to read here on mine because they come in so dark, but you guys should have your note-taking guide. And that says 7 centimeters there. So we have our formula, pi r squared. We substitute 7 for pi. We're going to be able to simplify. This is 49 pi. Remember, use your calculator. You can use 3.14, or you can use just 49 pi. But if I type in 49 pi into my calculator, I get 153.94. All right, we have to remember to label that. So it's 153.94 square centimeters, or 153.94 centimeters squared. It's no different than the polygons that we've studied in this chapter, in the fact that we need to keep them as units squared per area. All right, let's take a look at our next example. Now we're going to use the area. We have 380 square feet. And so we know this is 380 feet squared, so we know it's area. They want me to find the radius. So we're going to substitute what we know. We know 380 is equal to pi times radius squared, so we put 380 in for pi. We're going to divide each side by pi, and I like to actually go through and do that, and divide by pi on here. I don't type in 3.14. You can, so your answer is going to look a little bit different than mine. So I'm going to take 380 divided by pi, and I get 120.96. We're then going to take the square root of that. All right, so I take the square root of that, and I get about 10.998. Remember, so we're going to round that. So 99 rounds up to a whole number, so it comes out to about 11 feet. So this is a case where even with our rounding, we still end up with a whole number there, and that's okay. But more importantly, notice, ladies and gentlemen, it's not feet squared because we're finding the radius. It's just 11 feet. All right, so now in your checkpoints, ladies and gentlemen, I want you to find the area of the circle. So I'm going to do number 6 with you guys, talk you through number 6. 4, 5, and 7 are going to be on your own. All right, so you have to have those done to get credit. But when we take a look at this, we have the formula for area is pi times radius squared. But they give me a diameter of what is 12 feet. So what I'm going to have to do is find what the radius is. So if the diameter equals 12 feet, my radius is half of that. So my radius is 6 feet. So now I actually have information I can use. I have area is equal to pi times 6 squared. You cannot use that 12. You can't square it and then divide by 2. You have to find the radius first. So we're going to do pi times 36. I mean, you can type it into your calculator either way, but we get an area of 113.10, and this was in feet, so it's feet squared. So please make sure you're doing 4, 5, and 7 on your own. All right, let's take a look now at our last example, and we'll talk you guys through a couple of the checkpoints there. We need to find the area of just a sector of your circle. So what they tell us is we have a radius of 9 meters, so we can find area, but they're telling us our sector is 120 degrees. One thing that you need to know, ladies and gentlemen, is that an entire circle equals 360 degrees. So let's talk through what it's going to look like. The first thing you have to do is find the area of the circle. So we're going to do pi times 9 squared. And so when we do pi times 9 squared, or pi times 81, we get about 254.47. All right? So we've got our area of our circle there. We're now going to let x equal the area of the sector. That's what we don't know, so we're going to use our algebra there. So we're going to have a little ratio that we use. We know the area of the sector over the area of the whole circle, kind of like these corresponding parts. Area of the sector corresponds to the area of the whole circle, is going to equal the measure of the central angle over the measure of the entire circle. Well, we just found that our area is 254.47 .47, and that equals 120 sector to sector, whole circle to whole circle. So it's 120 over 360. We're going to cross multiply, so we have 360x is equal to 120 times 254.47. All right, no, they don't give us necessarily enough room there. You're actually going to do that multiplying. Most of you probably do that on your calculator right away. But we're going to take 254.47 times the 120. We get 30,536.4. We then have to divide each side by 360. So we're going to divide by 360. And we get an area of 84.82. So we have 84.82. And I'm going to put meters squared. So it's just setting up this ratio. So this should be something you guys highlight, something you turn back to as we go through there. So let's take a look at what they have us doing here. All right, so A represents the area of the entire circle. X represents the area of the shaded sector. So let's go through this. Remember, it's sector to the whole circle. So the area of the sector to the area of the whole circle is equal to the measure of the sector to the measure of the whole circle. All right. It says complete the proportion used to find x. Do not solve. So this is all we need to set up. So number 8 is done. You're going to do number 9 on your own. All right. Number 10, we're going to go through together here. This is 60 degrees, and we have 2 feet. So I have to find my area. So my area is equal to pi times radius squared. So my area is equal to pi times 2 squared, or pi times 4, however you're typing that in there. So I'm going to do pi times 4, and that gives me 12.57. So we have 12.57. That's the area. Now we're going to set up this ratio of x over 12.57 is going to equal to the sector over the entire circle. So remember, the entire circle, my area formula and my 360 degrees go together. You're going to cross multiply. I've got 360 times x is equal to cross multiply. We're going to do 12.57. We're going to do 12.57 times the 60 degree sector, and that's 754.2. Maybe I'll color that, draw that arrow as a blue arrow. So this is my blue arrow. That's my cross product, so I get 754.2. We then have a little equation we can solve, and if you look back at the previous example, it tells you the last step is to divide by 360. So if we divide by 360, we get an area of 2.10. And because it's area, it's going to be feet squared. All right? We're going to do 11 and 12 in class with a partner. All right, guys? So we'll do those to wrap up the notes tomorrow in class before you take off on your assignment. All right? Have a good evening.